Welcome to Structural Analysis 2 video series. Unit number 4, Stiffness Method. Lecture outline, numerical on continuous beam. Problem statement as follows. Analyze the two span continuous beam shown in below figure by stiffness method. Draw the bending moment diagram and shear force diagram. So in the given figure, AB span is loaded with the UDL 20 kN per meter. Span of AB is 6 meter. Moment of inertia is 2I. Span BC loaded with 80 kN point load at a distance of 2 meter from B and C. And CD is a cantilever portion, and at D there is a point load of 40 kN and the length of CD is 2 meter. Moment of inertia is I. At A there is a fixed support and B and C having a hinge support. The first step, as usual, calculate the degree of kinematic indeterminacy. So here there is rotation at theta B and at B and at C. So degree of freedom is 2 and those are theta B and theta C. Now second step, assign coordinate direction to unknown displacement. So these are the rotations. So assign the coordinate direction as anticlockwise positive. So let's call it as a d1 is equal to theta b anticlockwise rotation, and d2 is equal to theta c anticlockwise rotation positive. So both having a positive sign. Now next step, external force or moment acting in a coordinate direction. So coordinate direction at theta b and theta c, and those are rotation. So whether there is any external force in term of moment, that we have to see. Let's call them AD1 and AD2 with a. So now at C, if we consider this cantilever, if we make it separate, then the cantilever will generate the moment at end C, which is anticlockwise direction. 40 into 2 become 80, and same moment will be in opposite sense at CB, which is a clockwise sense of 80 kilonewton meter. So let take directly effect of CD over the C, and that will be the moment which is acting in the coordinate direction 2. There is no any moment at coordinate direction 1. So AD1 is equal to 0 and AD2 is equal to it become minus 80 kilonewton meter. Now next step, force in coordinate direction of a restrained structure, called it as a ADL. Now for that, make a structure restrained and find out the friction moment at each end at A and at B. So formula for same is WL square by 12. By putting the value, W is 20, L is 6 meter. So 20 into 6 square divided by 12 becomes 60 kilonewton meter. And for second is minus 60 kilonewton meter for end B. Now find out for the point load the effect of consider both end fix. Span BC having a fixed end moment, formula is WL by 8. W is 80 and span is of 4 meter. So 80 into 4 divided by 8 become 40 kilonewton meter. Positive for B end and negative for C end. Now the values are shown here, which are calculated above. So now the our position coordinates are 1 is here and 2 is here. So whatever the moment acting there, that we have to club. So ADL1 at location 1 or coordinate 1 or theta at theta B is minus 60 clockwise and plus 40 anti-clockwise, it become minus 20, and at C it will be a in anti-clockwise sense 40, so minus 40 and minus 40. So we taken the effect of cantilever over the C, and that effect is 40 at C, minus 40 at C. So this is about ADL. Now, next step is determine the stiffness matrix formed by forces in the restraint structure subjected to unit value of theta b and theta c, that is d1 and d2, corresponding to unknown displacement. Now, the we having two unknown, so matrix will be of 2 by 2 size, and the first first column of a matrix we will get by applying unit rotation at d1 is equal to theta b is equal to 1 in anti-clockwise direction. So here is our first coordinate and here is our second coordinate. So we are applying unit rotation at 1, that means theta b is equal to 1. So write down after one number, 1 and 2 indicate location of theta b and theta c, and the second number 1 1 which indicate the force is applied in the direction of theta b is equal to 1, that means coordinate 1 which is theta b. So you see, you will get the first coefficient of a matrix S11 and you will get the second coefficient of a matrix S21. That means you will get the first column of a matrix. Now let apply the unit force. So applying unit force at theta b, the both side will get rotate, and the if both side are attached at b, both beam will get rotate, and the location where you are applying unit force, that rotation is always that moment will always 4 ei by l. So this moment will be 4 ei by l for both sides. So here you see the S11 for BA plus S11 for BC we club together. So when we talking about AB, put the property of AB, moment of inertia of AB is 2I, so put here 2I, length of AB is 6 meters, so here you have to put 6 meter, and for the BC which is rotated, and the moment will be 4 ei by L, the property is I, and length is a 4, so put here 4. Now when we applying the rotation at theta B, the either side or the far end we always keep fix. So at our coordinates or unknowns are at location 1 and at location 2. So what happened at 1 and 2 due to the rotation at 1, that we have to see. So there is no any coordinate, our coordinate not at A, so don't worry about A point, but there is a coordinate at C, so half moment will be carrying which is 2 ei by L. So that is for CB. So moment of inertia is I, length is 4, so we have a value 2.33 ei and 0.5 ei for the first column by applying unit rotation at 1. Now next is apply the unit rotation at d2 is equal to theta c in a anti-clockwise direction, positive direction. Now applying that we will get the by applying unit rotation at theta c, we will get the second column of matrix, that means S12 and S22. So here is the first coordinate, here is the second coordinate. Now we are applying unit rotation at d2, that means at 2. So write down 2 number. So you see you will get the coordinate of a matrix, that means you will get the second column of a matrix. So let's find out. You are applying unit rotation at theta c, and that moment is always where you are actually applying, that is always 4 ei by L. So put the property of BC there. So moment of inertia of BC is I, length is 4, so you have a 0.5 ei, and after applying unit rotation here, the half moment will be carried at either end, that is always 2 ei by L. So property of BC we have to consider, the moment of inertia is I, length is 4, so we have ei. So now we having a second column of a matrix. Now the next step is superposition equation of equilibrium of forces. So the equation is AD is equal to ADL plus S into T. So AD1, AD2 and ADL1, ADL2 plus EI, taken EI outside, S11, S21, S12, S22, and unknowns are D1 and D2. By putting the all value which are calculated above, we have a two simultaneous equation. Solving these two simultaneous equation, we have theta b is equal to 19.23 ei and theta c is equal to minus 49.61 EI. So after this we have to use the uh, slope deflection equation. There we have to put these unknowns, and then we will get the end moment for each span. Let's stop here. Remaining part we will discuss in the next lecture.